Hello, hello, and welcome back. In this video, we're talking about angles between planes, more specifically parallel planes and orthogonal planes. So remember, given a plane, we can find a normal vector to it, and that's part of what defines the plane. So given two planes, we should have a set of two normal vectors. Now, that's our key to understanding how to define the angle between two planes and whether or not they're parallel or orthogonal. We look at the two normal vectors, we'll call them n1 and n2 here for plane 1 and plane 2. So we know that the two planes are parallel if n1 and n2 are parallel. So after computing n1 and n2, we would look to see if they're scalar multiples of each other. If they are, the planes are parallel. If not, they are not parallel. This also gives us a way of generating parallel planes. So as long as I pick a normal vector that is parallel to the first plane, and I say pick some other specific point on the plane, that'll give me a parallel plane to the first one. And then two planes are orthogonal, right? So that would be there's 90 degrees between, or pi over 2 radians between the two normal vectors. And remember how I can test for orthogonality. That is, I compute the dot product of the two normal vectors and get 0. So those are two special cases, parallel and orthogonal. In general, we can talk about the angle between two planes to just be the angle between n1 and n2, where that angle is between 0 and pi, as we normally do between two vectors. All right, so let's look at an example. In this example, we want to find an equation of the plane Q that passes through the point -2, 4, 1 and is parallel to this other plane. Okay, so we want to find an equation of a plane, which means we need, so we want to find an equation for our plane Q. What we need is a point on Q, and we need a normal vector. A vector normal to Q. All right, so that's what we need. We're told that it's parallel to this plane. So that means this normal vector is parallel to the normal vector to R, parallel to R's normal vector. So really, I could just use the normal vector for R. So that's what I'm going to want to work out is what's the normal vector here. That'll give me the normal vector for Q. And then here I'm given a point that's on my plane Q. And so there we'll have a point and a vector normal to Q, and we'll be able to get our equation. All right, so one thing we haven't directly talked about yet is given an equation of a plane like this, how can we sort of pick out the normal vector? Remember the form of this, of any plane, looks like ax plus by plus cz equal to d, where our normal vector n is a, b, c, and this d represents the dot product of a normal vector with a point that's on the plane. Right, so this could take various values, but what we want is this. And what we really want, is the normal vector to this. So I can actually read that off. It's just the coefficients. 3, -2, 1. So vector normal to Q is this one. N equal 3, -2, 1 is normal to Q. Right? It's normal to R, but Q is parallel to R, so the normal vector for Q is parallel to the normal vector for R. In fact, they're the same vector. That's the easiest way to do this. I don't need to go mess with a scalar multiple. Just keep the same normal vector. And then our point on the plane is -2, 4, 1. And then, so I'll say -2, 4, 1 is point on plane. All right, let's put this together. So equation of Q looks like, here's my normal vector. It'll look like 3x minus 2y plus z. So notice this part is exactly the same. Parallel vectors. This part can look the same. Doesn't have to, but that's an easy way to do it. And then I'm going to do n dot the position vector for this point. So I'll do n dot -2, 4, 1 is the other side of this. And so that is -3 times -2, that's -6. 4 times -2, so -8, plus 1 it looks like. 1 and 1. So that's -14, plus 1, that's -13. So when all is said and done, equation of my plane Q is 3x minus 2y plus z equal to -13. Pretty cool. All right, that's it for this video. See you next time. We'll talk about intersecting planes.